Hello everybody, today we are going to solve Leetcode 977 squares of a sorted array. Given an integer array norm sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. So we have an example here. Our input norms is equal to this array here, and the output is the square of the original numbers in the norms array sorted in non-decreasing order, which means increasing order from the smallest value to the largest value. We'll pass on to the explanation in a bit, but let's continue with the second example. Now you can see the second example is also similar. We have the squares of each value in the original array in our output array sorted in non-decreasing order. In increasing order, non-decreasing order is the same as increasing order. So there's a follow-up question here. Squaring each element and sorting the new array is very trivial. Could you find an O of n solution using a different approach? So let's first of all understand what this question is asking us to do. I'll pass it to my board here. I have the input array here, right? So we are just going to use it as our example and begin to explain. First of all, the question wants us to return an array of the same size as our original array, right? So we are going to create a new array, and then the values in our output array will represent the squared value of the values in the norms array, which is our original array, our input array. So the square of -4 is going to be 16. The squared value of -1 is going to be 1, 0, 9, and 100. Now this is phase 1. Part 2 of this question is asking us to return this value in a sorted order, in non-decreasing order or increasing order, if you will. So we are going to again iterate through this squared version and then sort them in non-decreasing order. So we are going to put the smallest value first, the second, the third one, fourth, and the last value, which is this. All right, now as you can see, performing this operation took us a little bit took us more steps than the question is asking us to do, because there was a follow-up question that says squaring each element and sorting the new array is very trivial. Could you find an O of n solution using a different approach? Now the different approach we are going to use is called the two-pointer approach, right? Now doing this, first of all, before going to the two-pointer approach, let's first understand what we are doing here. First of all, we iterated through the array and squared up each value, right? This already is O of n. Now we then sorted the values, the squared value, right, which is also, I think, n log n to square up to sort values in an array. Already this is not an optimal solution, and the question is asking us to perform this both operation, right, this operation 1 and 2 using an O of n approach. And the way we can achieve this is by using a two-pointer approach. Now what is a two-pointer approach? Well, a two-pointer approach is done by using two pointers, surprisingly, right? So the two pointers are basically two variables pointing at the lowest and largest values in our input array. So for example, in this case, we can have our first pointer, we'll call it left, at the beginning of the array, right, and pointing to the smallest value, and the right pointer is going to be at the end, right? So now this will help us identify which values are the smallest one between 2 points, right? So for example, if we took the value at, let's call this n at L, right, is going to be equal to -4. We can easily compare that to n at R, right? Now 2 pointers only work on sorted arrays, so keep that in mind whenever you're trying to use them. So now let's move on to the next part, which is where we begin to sort this array. Well, as you can see, sorting the squared version of this array will cause the array to lose its original order, right? Meaning if we squared up these values like this, 16 will be here, right? 1 will be here, 0 will be here, and then 9 we have 100. Now 16 is larger than 1, 0, and 9, right? So you can see this completely destabilizes the array, and meaning we need to check, right, each values before we decide where we are going to store them in our resulting array. So we'll create a second array called the result array. So I'll just put res is going to be an array, so with an array of equal size as our original array. So we are going to put some dash here to represent the positions of each value like this. Okay, now before we begin inserting into this array, we need another point, right, where we can determine the next position of the squared value in the resulting array. So we'll set that value at this point here. So I'll put I here. Let's call it J. Okay, so now we'll begin our iteration by comparing the values at L and R, right, between the 2 points. Now we can't compare these values directly because we want to store their squared version into this resulting array. So what we will do instead is compare their absolute values, right? So the absolute values will change the sign, right, in front of these values here. So for example, -1, the absolute value of -4, sorry, is equal to 4, right? So this doesn't even matter when we do 4 squared, right? 4 squared is the same as -4 squared, right? Both of these values will give us 16. So here's what we need to do. I will quickly erase this thing first. Let me move my face to the top here. Right. Okay. So we have J here, and we'll begin comparing the absolute values of each value at each point, right? So in our first iteration, we'll start by comparing -4 to 10, right? The absolute value of -4, which is 4, to 10. So since 10 is superior to 4, right, we store its squared value at J here. So we'll put J is going to be 100, right? The square of 10 is 100. So we'll then move J from here, right, to the next point. So J will move from here to the next value. And since we stored the value at the right pointer, we also need to move the right pointer to the front. So we're comparing -4, absolute value of -4 to the absolute value of 3. Obviously 4 is going to be the largest, and we store the square of 4 here. So this is going to be 16. And then we move this from here to here, right? We increment the left pointer to the right, and then we move J to this point here. So J will do the same thing. We'll compare these two values here. 9 is going to be the result because 3 is superior to 1, in absolute value terms, and then we will move j again. We move j forward to this point and move r from here to here. Now we have 0 and -1. The absolute value of 1 is 1, and comparing that to 0 is going to take 1 as the result. So 1 is going to be the largest, and the square of 1 is still 1. So we move j forward, and r, since we use the value of the left pointer, so we increment the left pointer to this point. Now the left pointer is equal to the right pointer, right? And at this point the values are equal, so we don't need to do any other thing. We just store the square of that value in this array here. So the result here is going to be equal to 0 squared, which is literally 0. So this is how we can solve this problem, and the solution in terms of code is here. So we use a 2-pointer technique. So we can see we have the left and right pointers here. The left is always at the index, at the beginning index, which is index 0, and the right is at the last item in the array, which is the length of the array minus 1. And you can see I'm just storing the length of the array in n. And we have the index, which is equal to n minus 1, right? The index we are trying to move each time we the index at which we store the values in the result. So it's also an array, a variable we created here. It's starting from the end of the array, and we create a result array and fill it with zeros, right? So our iteration goes this way. We have the left is less or equal to right. So the as long as this condition is true, we'll keep performing these checks here. And you can see we compare the absolute values of the number at the left pointer to that of the number at the right pointer, and store the values in the array, increment the left pointer, and we do the same thing for the right pointer, and we decrease the value of the index, and at the end of the day we return the result. So this solution is O of n, and you can see we have the results here. So it's did well in terms of time complexity, and in terms of memory not so much, because we are creating a new array here which consumes memory apparently. All right, that's it for today, and I'll see you in the next one. Bye.